Excuse me, pre-algebra students. All right, we're going to do a quick review over the things we've been talking about the past week. First of all, we're going to convert to scientific notation and convert to standard notation. You go ahead and pause the video. My answers are going to appear for questions 1, 2, and 3 really quick. All right, if you're ready to see them, here they come. Oh no, I'm not on. There we go. Okay, remember, to be in scientific notation, I need a single digit number, then the decimal point. I know that my decimal point is here. I know it needs to be here. So in scientific notation, I am going to get 6.23, and I'll multiply by 10, and I'm going to count how many places I went. 1, 2, 3. 10 to the third power. All right, the rest of the answers are going to magically appear. I walked you through one. Hopefully you agree with my answers. There are my answers. Hopefully you, on problem number 2, notice there's a negative exponent. I need to move my decimal point in the right direction. And since it was a number smaller than 1, my exponent is going to be negative. Now on this one, some of you might be thinking, geez, the answer was already in scientific notation. Nope, the decimal point's in the wrong place. I divide by 100, or 10 squared, and thus I must multiply by 100, or 10 squared. So I get 7.314. and it becomes 10 to the 8th power. All right, let's go the other way. There's 2 examples. Go ahead and pause the video, and my answers will show up momentarily. Okay, there are my solutions. Hopefully you got the same thing. This 6.12 times 10 to the negative third, I have to move the decimal point 3 places. 1, 2, 3. Or in other words, I have to divide by 1,000. And so I end up with this. If you wanted a lead 0 here, you could do that. Nothing wrong there. Then on this one, I'm multiplying the number by 10 to the 5th, which is 100,000. So this number has to get larger. The decimal point's going to move to the right 5 places. It was here. 1, 2, 3, 4, 5. And there you go, 780,000. All right, I've got 2 addition ones and 2 subtraction ones. Knock yourselves out. Go ahead and pause the video and see if you can get the right answer. Okay, here are my solutions. I'm going to kind of cover them up as I talk about them. All right, the first one, the addition. First thing I checked was to see if my exponents were the same on my tens, and in this case they were. So I could just go ahead and add, and all I did was add 3.2 and 1.3. I get 4.5, or 4 5/10 to the 10 times 10 to the 5th power. All right, number 7. My exponents do not match. I changed the 7 to the 9, which is the same as multiplying by 100, or 10 squared. So over here I had to divide by 10 squared, which moves the decimal point 2 places left. I rewrote my addition problem, taking the 1.11 plus 0.0819, and I put the 2 green zeros in as placeholders, so that when I add it, 9191 decimal point and 1, and it's times 10 to the 9th. All right, very good. Let's shift over here. Number 8 is a subtraction problem. My exponents did not match. I'd like to change the smaller one to the larger, so I turn the 2 into a 3. Which is multiplying by 10 to the 1st. So then over here I have to divide by 10 to the 1st, which moves the decimal point 1 place. So I rewrote my subtraction problem, 8.63 minus 0.24, and I get 8.39. And I have 10 to the 3rd. I make my exponents match, and then I don't do anything with them. I just bring them along for the ride. Number 9 is very similar. I turn the 4 into the 5, which is multiplying by 10 to the 1st. So I divide by 10 to the 1st here, changing it to 0.31. 4.81 minus 0.31 is 4.5 times 10 to the 5th power, and there you go. All right, we're tearing through this review. Okay, multiplication, and division. There's 4 problems. Let's see what you can do with them. My answers will appear momentarily. Okay, here's 4 possible answers, and I will tell you 3 of them are incorrect. 3 of them are incorrect. Check it out. See which ones are wrong. Well, let's see. This one's 60 times 10 to the 8th. I don't like that because I'm not supposed to have a number that large. So I'm going to divide by 10 there, multiply by 10 to the 1st there, and I'll get 6.0 times 10 to the 9th. Okay, that one looks a lot better now. Number 11, 6.3 times 10 to the 6. 2.1 times 3 is 6.3. 10 to the 8th plus 10 to the or times 10 to the negative second. 8 plus negative 2 is 6. This one's good. All right, here, same thing as number 10. I got a number that's too big. I'm going to divide that number by 100 to get 1.20. Scoop, scoop. All right, if I divide by 100 there, I have to multiply by 100 over here, or 10 to the second. And so I get 10 to the 11th power. 9 plus 2 is 11. Right, that is 11. Okay. Coming down here, 90 times 10 squared, same mistake. Same type of mistake. Decimal points in the wrong place. I need to divide by 10, turning it into 9, which means I need to multiply by 10, turning it into 10 to the 3rd power, and there you go. Pretty simple stuff. Okay, we got some story problems here, and it says a light year is the distance light can travel in 1 year. Or, wow, that is a big number. Let's see, millions, billions. 5,880,000,000,000 miles in 1 year. 5,888,000,000,000 miles in 1 year. Express this number in scientific notation. Well, I see the decimal point is here. I need it to be here. My decimal portion of scientific notation answer will be this. And then I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 10 to the 12th power. That is one monstrously large number. The star Vega is 23, or 2.3 times 10 to the 1st light years from Earth. How many miles is it from Earth? Express your answer in scientific notation. Well, I know it's 2.3 times 10 light years. And how many miles does light travel in 1 year? Well, it travels this number here in scientific notation. So I need to multiply. I need to do 5.88 times 10 to the 12th power. All right. So I'm going to multiply the 2.3 times the 5.88, and my calculator told me that was 135.24. Now I don't like that number. You probably realize it's in the wrong place, but I'll fix it in a minute. Okay, the decimal point's in the wrong place. All right, I'm going to do 10 to the 1st times 10 to the 12th, and I'm going to get 10 to the 13th power. Now, going back to what was wrong here, this decimal point needs to be over here, and moving it 2 means I divided by 100, or 10 squared. So I have to multiply by 10 squared over here, giving me the new answer of 1.3524 times 10 to the 15th power. That's the number in scientific notation. That is one monstrously large number. Okay, monstrously large. All right, now, last question, and then we'll wrap it up. The star Canopus is 650, or 6.5 times 10 to the 2nd light years from Earth. How many times farther is Canopus from Earth than Vega? Well, how many times more? That's a division problem. So I'm going to take that number and I'm going to divide it by the 2.3 times 10 to the 1st. So my calculator will tell me 6.5 divided by 2.3, and I'm going to get 2.826, and that's rounded, times 10 to the 1st. Now that answer doesn't make a whole lot of sense to me being in scientific notation. I'm going to convert that to standard notation, 10 to the 1st, so I'm going to move the decimal point one place, and I'm going to get 28.26. So my answer, and this makes more sense to me, is that it's more than 28 times farther. more than 28 times farther from Earth than Vega is. It's pretty incredible, because something being 23 light years away, that means if you were traveling at the speed of light, it would take 23 years to get there. So you guys are 13, 14, 23 years later, you're 36 or 37. Okay, it's going to take that long. But this one is more than 28 times farther than that. In other words, at the speed of light, you couldn't get there. You'd have to live for 650 more years to get to Canopus. All right, Mr. Lawrence signing off. Have a good weekend, everybody.